Help support our coverage with a free account on Privacy, the service that keeps you protected when shopping online. Get $5 to try it now by using promo code QZZ2J. And with Blueberry, the community that gives creators the power to make money, get detailed audience measurements, and host their audio and video. Get a 30-day free trial by using promo code Blueberry004.
I want to welcome the CEO of Canatu. I hope I pronounced that right. And Juha. I'm going to destroy your last name. So welcome to the show.
Thank you very much. My name is Juha Kokkonen.
I would have. Okay.
Yeah.
Thank you so much for correcting me. So tell me about your company and what you guys are doing here at CES.
Yes, we are a material company. We are doing carbon nanotubes. And these carbon nanotubes are really tiny, like 2 nanometer thin tubes.
Now that's tiny, 2 nanometers.
That's super tiny.
Can you even see the hole?
No, it's like they're million times thinner than a single paper sheet.
That's right.
So what you can do based on those is that in simplistic manner, I'm calling that they are like the boiled spaghetti. And like boiled spaghetti, you can bend it.
Yep.
And you can stretch it.
That's right.
And then these are superconductive.
Oh, they are?
They are. So what you can do then, okay, what we are doing firstly there is that we have done, capacitive touch. That is used for smartphones, nowadays for automotive and so on. They are flat. Or in best ways, they are foldable. Now you have a couple of ones.
Yeah.
With our material, you can make this capacitive touch with any shape.
That's interesting.
Any shape with 1 millimeter bending radius. So that gives you opportunity that, for example, we have started in automotive industry where you can make your cockpit that is capacitive touch, and it can be any beautiful shape. It does not need to be like boxy flat, but it can be really beautiful.
That's incredible.
Yes. And other point there is that because you can have a shape there. If you remember your old car with this volume button, knob that you are turning volume high enough. Mm-hmm. When you are doing that one, you don't need to even watch that one. You have a muscle memory to doing that one. In nowadays, when we have been introducing huge displays there with icon-based UI, while you are driving your car and you are supposed to adjust this volume there.
That's right.
It's difficult. You are losing kind of the attention for driving, and there's
you're doing that.
We are doing that one. So we are doing 3-dimensional capacitive touch sensors. Second, what we are doing is that in the automotive industry, autonomous driving is coming.
Yep.
You have a lot of sensors. You have camera sensors. You have lidar sensors. You have radars there.
Yep.
That makes that you are keeping the line. You have adaptive cruise. And eventually, you don't need to drive yourself at all. What we are doing there, they are working today in perfect day in California or here in Vegas.
That's right.
But what if it is snowing?
That's the country I live in.
What if you have frost?
That's
right. If you have a fog there in front of the sensors, they stop working.
They do.
They say, take a control.
Yep.
What we are doing, these carbon nanotubes are also ballistic, like our CTO is saying, conducting heat. So this transparent 3-dimensional network can remove frost, fog, ice, anything from front of your sensors. And therefore, suddenly, your autonomous driving is working with any weather.
I was driving from the Detroit area down to Columbus, and it was snowing, and there was ice on the road, and it wasn't to the point where it was unsafe to drive with cruise control. I could still have cruise control on.
Right.
But all of a sudden, my cruise said, no, because adaptive cruise is no longer available, I'm not going to engage. And I'm like, what's going on? And the next rest area, I stopped and had to wipe off the sensors.
Exactly.
Because the sensors had gotten iced over.
Exactly. You don't need to do that anymore with our
So basically self-defrosting.
Exactly.
Another place that's a problem is on airplanes, too.
True.
Airplanes have to be de-iced. It's not necessarily the top of the wing, but it's that leading edge area that if it gets too much ice on, it can become a problem.
Exactly.
So it's so thin, you could almost put a layer on an aircraft skin, too. I don't know if it's that durable, but It is interesting. So how, with this tubing being so thin, how do you work in this in a? Is it layered, or how are you actually? How's the manufacturing process work? This has to be difficult.
Yes. So basically, we have our patented technology both for the material itself, as well as for the synthesis, how this is manufactured. Typically, we do have their substrate material. So we are doing the deposition on top of the substrate material. So you can have a different type of substrate materials. If you want to make the stretchable solution,
sure,
you need to have like polycarbonate based. Typically, PET is used. Sometimes you might use polyimide when you have a really like the stretchable. So you are doing the deposition on top of the substrate.
So you say they're conductive. So what kind of power loads are these handling?
I think that because it is carbon-based, it can handle almost any power load.
Really?
So the power load is not a problem. In car cases, typically you have 3 different types of solutions. You have 12 watts is the kind of the most common one. Then you might have 24 in commercial vehicles. And now there starts to be also like 48 voltage systems when it comes to EV cars.
Right.
So with all of those, we work perfectly well.
And it's not necessarily the volts; it's the amps is what causes the issue and how much power you're trying to draw through them. So do you see this technology also being used in supercomputers? Is there a way to apply it there as well, or?
Yeah, I think that you are talking that can we conduct heat away, like in superconductors or mobile phones, heat spots and so on. This is not the product yet what we have done.
Okay, I see.
I think that this is something that we could use our product. I think that the graphene is the alternative solution for that one as well. So yes, it can be used for that one, but as we are still a reasonably tiny company, we are focusing
on the automotive.
Yeah.
So how's the response then been from the industry? Are people pretty excited about the potential of what they can do here?
Exactly, super excited. We have had an excellent show here. We have had a great success so far.
Oh, good.
We have first cars running on the streets, couple of new SOPs like start of productions in this year with the cars, so it's amazing time.
Well, I'm going to tell you, this is really super cutting edge, folks, and I'm sure we could get really deep down in the dirt with talking about this. And I know we've got some of you out there that are engineers. We've got folks that are all the way from engineers to, we've got people here that have probably are like, I don't know what these guys are even talking about. So what we're going to say?
I'm the first one. I am fascinated by all of this.
Yeah, and if you think about what he has described here, you're like, it's pretty cool,
Yeah, for sure.
So what's the website? Is it Canatu.com? Canatu.com. So Canatu.com is the place to go. Definitely check it out. So I bet you have all the information on the technology, how it's being applied. You have some demo videos over there too?
We have a lot of demo videos there. And if you come to our booth in South Hall 2, you will see a lot of excellent demonstrators there.
Yeah, outstanding. All right. Well, I'm sure we're going to hear more from you. Is this your first year at the show, or how long have you guys been in business?
We have been here already. This is the third time for us.
Third year.
Yeah.
Well, good. And I'm glad to see you're finding success. So thank you for coming on the show.
Thank you for the interview.
Yeah, absolutely.